Let's start with practice paper 3. So first question in practice paper 3 says two charges 3 nanocoulombs and 5 nanocoulombs are placed 30 centimeter apart. The force acting between them will be how much? So let's recall our Coulomb's law. Coulomb's law says F is equals to K Q1 Q2 upon R square. Be very careful. This is force constant K. And what's the value of K? K here is 9 into 10 to the power 9. The charge, the first charge which is given here is nano. Nano means 3 into 10 to the power minus 9. Okay. Let me repeat again. Nanocoulomb means 10 to the power minus 9. And what's the charge on the second one? 5 into 10 to the power minus 9 whole divided by separation square. What's the separation between the two charges? 30 centimeter. So 30 into 10 to the power minus 2 whole square. Sir, why 10 to the power minus 2? Because it's in centimeters. You have to convert it into meters. Okay. So let's expand it. This will be 9 into 3 into 5. Let's separate the power. 10 to the power minus 9. 1 9 cancels. You're left with single minus 9 whole divided by 30 square. 30 square is 900 into 10 to the power minus 4. Correct? So now 9 and this cancels out. You're left with 100 here. Okay. And let's make it 15 into 10 to the power minus 9 and 110 to the power minus 4 minus 2. Minus 2 goes up, it will become plus 2 and it will be 10 to the power minus 7 newtons. What's that? That's our force. So force is 15 into 10 to the power minus 7. So that's option A. Question number 2. Question number 2 is, if the charge Q1, if the Q1 is the charge on the first metallic sphere and Q2 is the charge on the second metallic sphere, the force acting between them will be repulsive. Repulsive if they both are like charges. Like charges means either both are negative or both are positive. So if both the charges are negative, for example, just taking an example, minus 2 into minus 3. So both are negative. If you multiply them, you will get a positive, right? So Q1 into Q2 will be greater than 0 if both are negative or both are positive. For example, one charge on first metallic sphere is 5 coulomb and the second one is also 5 coulomb. So when you multiply, you will get 25, right? But if it is minus 5 and it is minus 7, let's say, any number, but negative multiply, again positive. So if Q1 and Q2 product is greater than 0, the force will be repulsive. Okay. If it is less than 0, it is attractive. Okay. Let's move to third question. Question number 3 says, two charges, this and this, are separated by a distance of this. Find the force. So direct question. Let's use our Coulomb's law. F equals to K Q1 Q2 upon R square, right? Now what is Q1 here? Let me write here what is given data. So Q1 here is 10 microcoulomb. Micro, if you don't know, it's 10 to the power minus 6. Q2 is minus 5 microcoulomb, 10 to the power minus 6. Okay. Negative sign is not considered because we know Coulomb's law, it is in modulus, right? So you don't take the negative sign. Distance here, R, is 5 centimeters. So 5 into 10 to the power minus 2. Correct? Because it should be in meters. Correct? Let's substitute here in the expression. So K is nothing but 9 into 10 to the power 9. Charge Q1, which is 10 into 10 to the power minus 6. Charge Q2, 5 into 10 to the power minus 6. Let me remind you again, we don't take the negative sign. Whole divided by R square, which is 25 into 10 to the power minus 4. Because square of 5 is 25 and 25 into 10 is to minus 4. Correct? So let's separate the magnitudes. 9 into 10 into 5 whole divided by 25 into 10 to the power 9 and 10 to the power minus 6, 10 to the power 3. So 10 to the power 3 left and 1 10 to the power minus 6 as it is left. Let's take the 10 to the power minus 4 up, it will become plus 4. Now 5 5s are and 5 2s are. 2 9s are 18. 18 into 10 to the power 3 minus 6 minus 3 and plus 4 1. 180 newtons. That's your answer for this particular problem. So correct option is option B. Let's move to question number 4. So question number 4 says, there are three charges Q, Q and 2Q are placed at the corners of an equilateral triangle. And what's the side of this equilateral triangle? A. The net force acting on 2Q must be. So let's first make an equilateral triangle, right? So let's say this is our equilateral triangle and here the charges which are present are Q, Q and 2Q. Each side here is A. Correct? we have to find the force on this 2q charge, correct? So first of all, let's see what happens and what kind of force acts here. We can see, let's call it as A, B and C. We have to find the force at C. You can see that the charge at A is positive Q. Charge at C is again positive. Positive, positive, there will be a repulsion. Okay. In which direction? It will be along this direction. Clear? So this is the repulsion along the line joining. Okay. And where will be the repulsion from B to C? It will be along this line. Both are repulsive forces. Why they are repulsive? Because both are positive charges, right? Positive charges repel each other, right? In this direction. So let's put here roughly force on C due to A, force on C due to B, correct? What will be this angle between both the forces? Angle will be 60 degree. Sir, how you know this is 60 degree? We know this is an equilateral triangle. So this is 60 degree. So vertically opposite angles should be 60 degree. Great. Okay. This is the first thing you have to do. Okay. You can't randomly find the force and you can simply add them. No, because these are vectors. You have to use the resultant formula. So what is our force on C due to A? That will be K. Charge on C, which is 2Q. Charge on A, which is Q, upon separation between them, A square. Why? Because it's an equilateral triangle. Each side is A. Similarly, force on C due to B will be K. Charge on C, 2Q. Charge on B, again Q, upon A square. So this is 2 times KQ square by A square. And this is also 2 times KQ square by A square. Correct? Both the forces are equal in magnitude, but not in the same particular direction. They are inclined at angle 60 degree. Be very careful. You have to use the resultant formula. Sir, what is the resultant formula from class 11th? A square plus B square plus 2AB cos theta. Let me remind you, this is our resultant of any two vectors inclined at any angle theta. Sir, can't we add them directly? No, because they are vector quantities. You have to first find the direction and the angle between them. Then you can add them using this. R means the total sum. So let me write here the net force acting on C will be equals to root under A square. A square is FCA square plus FCB square plus 2 times FCA FCB cos of 60 degree, because angle between them we found as 60 degree. Secondly, if you look at the magnitude of FCA and FCB, they are same, right? So you can call FCB also as FCA because they are same. Magnitude wise you can see they are same. So you can write here FCA square plus 2 times FCA into FCA square. From where I got this square? CA and this CA. Cos 60 is half. From trigonometry, cos 60 degrees half. So let's cancel this with this. And we left with here root under, be very careful, FCA, let's call it as apple. 1 apple plus 1 apple plus 1 apple. You left with 3 apples. Apple is FCA. So what is, when you take it out of the root 3, and this will become FCA. And what's FCA? It will be root 3 times 2KQ square by A square. So this is our resultant force on C, 2 root 3 KQ square by A square. Option A. I hope this is clear. This is question number 4. And let's move to question number 5. Question 5 says here, 3 charges, this and this, are placed at the corners of an equilateral side, okay, A, the net force acting on charge 3Q. So quite similar way to proceed. Let's draw an equilateral triangle here. This is our equilateral triangle. And on this equilateral triangle, we have A, which is Q, B, which is 2Q, and C, which is 3Q. Question says, find the force on C. So we will proceed in the same manner. Okay, let's make here our directions. So here it will be in this direction. Okay, and this will be in this direction because repulsive. Both are repelling. Both means the charge on A is repelling the C. The charge on B also repelling the C in this direction. This is FCA, FCB. Okay, always along the line joining. And again, you know, this is our 60 degree. Correct? Okay, let's find the magnitude. So force on C due to A will be K. What is the charge on C? 3Q. Charge on A, Q, whole divided by separation is A. Yes, A square. This gives us 3 times kq square by a square. Correct? What's our force on C due to B? K, charge on C, charge on B upon separation square. So this will be 6 kq square by a square. We found the forces on both. Now, are they equal? No. So be very careful here. Theta here is 60 degree. Correct? So let's use the resultant formula. So our net force on C using the resultant formula will be root under FCA square, FCB square, 2 times FCA, FCB cos of 60 degree. Okay. Next, what you will do? You will substitute the values because they are not equal. So let's put it 3kq square by a square whole square plus FCB. This will be 6kq square by a square whole square plus 2 times FCA. 3kq square by a square into 6kq square by a square. And what is cos 60? Half. Substitute these values. Now let's simplify it. This 2 and this 2 will cancel out. Correct? Now we left with root under. Now pay attention how to simplify such a weird outcome. This will become 3 3s are 9, and let's keep this in bracket only. I just took the 3 outside the whole square. So when you take 3 outside the whole square, it will become 9. Similarly, here it is 36 kq square by a square. And there it will be 3 into 6, 18, and keep them together kq square by a square. Now call this kq square by a square as an apple. 9 apples, 36 apples and 18 apples. Let's calculate the value and figure out how many apples we get. So 9 plus 36 plus 18. That gives us root under 63 apples. What are our apples? Kq square by a square whole square. Now when you remove the root, you will get root under 63 kq square by a square. Right? I removed that root. Now 63 you can make it as 3 root 7. But let's see, is there any direct option? Yeah, option B is there. 63 kq square by a square. This was 5th question. Okay, let's move to our question number 6th one. Quite similar problem. So let's here make an equilateral triangle. Okay, so this is our question number 6. It says 3 charges q minus q. Let's make it q minus q and 2q. Till now we didn't had any negative, right? Now we have a negative charge also, so be very careful with that. Side is same. Net force on minus q you have to find, right? Okay, now pay attention what happens if there is a negative charge. If there is a negative charge, this negative charge will be attracted towards this positive charge, as well as it will be attracted towards this positive charge. So let's call it as A, B, C. Okay. B is attracted towards A in this particular direction. So let's make an arrow here. Okay. And B is attracted towards this C charge in this particular direction. Okay. So this is the force on B due to C. That is the force on B due to A. What is the angle between them? Obviously, this is an equilateral triangle, so it will be 60 degree, right? Okay. So angle between them is 60 degree. Let's find the magnitude. So force on B due to A will be equals to kq square by a square. But wait, sir, why you are not taking the negative sign? Because I have already included that negativity inside the arrows. If it was positive, this arrow would be not in this direction. It would be in the opposite direction, right? So that is already done. Okay, so don't take the negative sign again and again. So force on B due to C will be again K into Q into 2Q whole divided by A square. So that will be equals to 2KQ square by A square. Are the magnitudes same? No. And what is the theta here? 60 degree. So let's see how to simplify it further. So let's recall our resultant formula. Force on B will be root under FBA square FBC square twice of FBA FBC cos of 60. Now we have already used, so I am directly putting half. That will cancel out here. Cos 60 is half. Now let's substitute the values of our FBA and FBC. Root under KQ square by A square whole square. FBC 2 times KQ square by A square whole square plus FBA KQ square by A square into 2KQ square by A square. Next is, this will be root under, okay, let's simplify further, KQ square by A square whole square. And when you take this 2 out, it will become 4KQ square by A square whole square. And that will become 2 times multiplying them together, KQ square by A square whole square. Again, take the KQ square by A square as an apple. 1 apple, 4 apples and 2 apples. So 4 plus 2, 6 and 1, 7. Root under 7 apples. KQ square by A square whole square. And when you remove the root, you will be left with root 7 KQ square by A square. Correct? So this is our correct answer. Root 7 KQ square by A square. Option C for question number 6. Let's move to question number 7. It says 2 charges Q1 and Q2 are separated by a distance D. If both Q1 and D are doubled, the force becomes how much? So Q1 is getting doubled and the distance is also getting doubled. Then what will be the effect on force? So let's see what happens initially to the force. So 2 charges, this is Q1, this is our Q2, and separation between them is D. So force will be K Q1 Q2 upon separation D square, right? Now they are saying that Q1 is getting doubled, which means it becomes 2Q1, and separation also becomes doubled, that is 2D. This will become Q2. What will be the new force? So let's call it as F dash, that's a new force. That will be equals to K new charge on Q1 into Q2 still remains Q2 separation square, new separation square, which is 2D square. So this will become F dash is equals to 2K Q1 Q2 and 2 2s are 4D square. 2 by 4, which is 1 by 2. When you cancel 2 and 4, 1 by 2. And what is this? K Q1 Q2 upon D square. What is K Q1 Q2 upon D square? You can see here, this is our force. So new force will be half of the previous force. Correct? This is our answer to this. So half, it will become half. Option B for 7th one. Question number 8 says, what is the unit of permittivity? Now let's recall what is permittivity, because we are still using it as K. Now we will write K is nothing but 1 by 4 pi epsilon naught. Okay. Q1 Q2 by R square, that is our Coulomb's law. Epsilon naught is permittivity. So let's take epsilon naught on the left hand side. It will become Q1 Q2 upon 4 pi FR square. Correct. Now 4 pi is a constant. It won't have any unit. What's the unit of charge? Q1 and Q2, that's Coulomb. So Coulomb into Coulomb, Coulomb square upon force is in Newton. R is separation will be meter square. So Coulomb square per Newton meter square, that's option D for question number 8. Okay, direct. Next question, let's move. Dimensions of epsilon naught. Okay, so we have already calculated the units. What's our unit for epsilon naught? Let me recall. It was Q1 Q2 upon 4 pi force and R square. So we have unit of our epsilon naught as Coulomb square per Newton meter square, right? Now in case if you don't know the dimensions, okay, then let me remind you, Newton is the unit for force, and force is nothing but mass times acceleration. Mass is kg, acceleration is meter per second square, right? So that's 1 Newton. So what is the dimensions of that? Kg is mass m1, length L1 and t minus 2. That's the dimensions of force. And meter square. So and meter square is simply length square. So meter square is simply length square. And the dimensions of Coulomb. Coulomb is charge. Charge is current into time. We have to put it in terms of current. A into t. So let's substitute here. Coulomb square will be AT whole square upon Newton m1 L1 t minus 2 into meter square L square. Let's expand the squares so that it becomes simple. A square T square whole divided by M1 L1 and L2 L3 T to the power minus 2. When you take it up, okay, M will become minus 1, L will become minus 3, T will become plus 4, okay, and A square. That will be the dimensions of epsilon naught. That is option B. So correct answer for 9th one is option B. Let's move to the last question of practice paper 3. That is our 10th one. 4 charges, this are placed at the corners of a square having side length this, then the net. Okay. So here we have a square. So let's draw a square here. This is our square. Just assume it, though it looks like a rectangle, but it's a square. Okay. And here we are putting the charges Q, 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 and okay. So let's go into the same order. Q, 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 and minus Q. Okay. Let's call it as A, B, C, and D. Find the net force acting on charge at minus Q. So first of all, we know that minus Q will be attracted in this direction. This is force on D due to A. Force on D due to C will be in this direction, attracted. And even there will be a force in this direction also, force on D due to B. Be very careful with the third one, okay? Because there are 3, but in the resultant formula we have only 2 forces at a time. So be very careful with this problem. What is the force acting on D due to A? Pay attention. K Q square by A. What is our force on D due to C? That is K Q square by A. And what is the force on D due to B? That is K Q square by A. Magnitude wise, all of them, A square it is. Magnitude wise, all of them are same. Okay. So you can write simply forces are FDA is equals to FDC is equals to FDB. But you can't add directly as they are vectors. So we will have to find the resultant. So first of all, the best approach is the angle between DA and DC, that is 90 degree, because it's a perfect square, right? If it's a square, then it is perfectly 90 degrees. So let's start with the resultant R of whom? FDA plus FDC plus 2 times FDA, FDC, and what's the angle between them? Cos 90. Why I chose this? Because cos 90 is 0, so this last factor becomes 0. And it becomes quite easy for us to understand. So FDA and FDC we left with. So FDA square. And even FDC is equal to FDA. So let's put it FDA square. Adding both of them, it will give us 2 FDA square, right? And when you remove the root, you will get root 2 FDA. So this is the resultant of these two. Now listen very carefully. The resultant of these two, okay, will be this. And from 11th standard, we know that resultant of any 2 vectors will be along the diagonal this. Using parallelogram law of vector addition, that will be equally inclined here with FDA and FDC. So this is our R, correct? Now R, wait a minute, I did a small mistake here. FDB is not having root 2A. Why? Because the gap between D and B, listen very carefully, it is diagonal. So if it is diagonal, what's the gap between this? This will be DB square, right? And what is DB? What's the diagonal of a square? Root 2A. KQ square by root 2A whole square. So from where you got root 2A? If you take this triangle, which triangle? Our DCB, this side is A, this side A is A. Pythagoras theorem will give you this also, root 2A. So Pythagoras theorem, perpendicular square, base square equal to hypotenuse square, that you can apply here and you will get, okay. So what's the force on DB? KQ square by 2A square, okay. This is our force. So be very careful. DB is different force from DA and DC, okay. Coming back to this, so resultant of DA and DC, we got it along R. Now we have to again use the resultant formula to get these two. So what will be now this? See, both are inclined in the same direction. So if they are inclined in the same direction, you can add them directly, okay. Or if you want to use resultant formula, let me solve it for you. If two vectors are inclined in the same direction, a square plus b square plus 2ab, and what's if they are inclined in the same direction, what will be theta? 0 degrees, so cos 0. And what is cos 0? 1. So cos 0 is 1, so you can remove this factor here and you're left with this. And this is nothing but root under a plus b whole square, right? Square and root cancels, you're left with a plus b. So you can directly add them instead of putting it in resultant formula. When we add them directly, if theta is 0 degree, if both the vectors are inclined along the same direction, so net force F acting on D will be equals to force resultant of the two. Resultant means the sum of these two, FDA and FDC, plus the net force acting along DB. So resultant of this is root 2, and what is FDA? That is KQ square by A square plus KQ square by 2A square. So let's take KQ square by A square common and we left with root 2 plus half. Let's see if we have such an option here. So root 2 plus half KQ square by A square. Yes, that's option A for question number 10. That's our paper 3.